Hey, welcome back. So as I look forward to 2024, I want to look at one of the technologies from 2023, which is going to play a massive impact in 2024. And that is Retrieval Augmented Generation, or the RAG pattern. And in particular, we're going to look at a new technology called Jina AI, which I think is going to blast open that field in 2024. So before we can look at Jina AI and the impact it's going to have, we actually need to understand what Retrieval Augmented Generation is in the first place. And to do that, we need to look at one of the problems with large language models today. So if I just type in this simple query into GPT-3.5, what was the first machine to run algol W, you see it's going to come back and it says the SDS Sigma 2. But actually, if I run that exact same query again, I'm going to get a completely different answer, the Electrologica X1. However, if I run GPT-4, for example, it is actually going to come back with the right answer, which is IBM System 360. But as you can see, GPT-3.5 is just making up answers all the time. So far I've asked the same question and it's giving me 3 different answers. And this is not a problem that is exclusive to GPT. If I run the same query in something like the new Mixtral AX7B version, you see it's came up with CDC 600. And again, if I run the same query on a different model, so let's take the Llama 270B model, and we ask the exact same question, you're going to see it comes back with the IBM 704. So no matter what model you're using, they're all making up answers. By the way, GPT-4 does have the right answer. And I think that one question properly sums up the problems with large language models, which is if it doesn't know the answer to the question, i.e. that answer is not within its training data, then it will try and please you and make up an answer, and that is essentially called hallucinations. So how does the RAG pattern help solve that problem of hallucinations? Well, instead of using the knowledge that's within its training data set, you're going to instruct the large language model to use a data set that you provide to answer the question. And if it doesn't have the answer, you're going to instruct it to say, I don't know. Now, this has a couple of other positive implications as well, because the large language models are trained on either public or proprietary data, but it's probably not trained on your data. So if you want to have a large language model that is able to answer questions that come from your own data sets, whether that's something like training manuals or company operating procedures, etc., then you're going to be able to use the large language model in conjunction with your own data to get really precise answers back to those questions. And that's really the problem that RAG is solving. Now that we understand the problem that the RAG pattern solves, let's actually look at how we can answer that question that GPT-3.5 got wrong, but this time using the RAG pattern. So to answer the question of what machine did the algol W originally run on, I need a source of truth. And in this case, the source of truth is actually a paper created by a guy called Tony Hoare, which is called The Emperor's Old Clothes. And it comes from the 1980 ACM Turing Award lecture. And again, Tony Hoare is an absolutely famous and amazing computer scientist. And one of the things he helped develop was algol W. He worked on all the algol specifications, and he worked with that with Nicholas Wirth. So if I look in the paper here, you can see we had a draft of an excellent and realistic language design, which was published in June 1966 as a contribution to the development of algol in the communications of the ACM. It was implemented on the IBM 360 and given the title algol W by its many happy users. It was not only a worthy successor of algol 60, it was even a worthy predecessor of Pascal. So if we accept that document as the source of truth, what I have done is I've taken that document and just converted it into a plain text format. Now, as you can see, it's quite a big document. It's around 500 odd lines. Now, the big problem with such a document is that it's probably too big for one of the large language models to be able to handle. If I just pasted that in to one of these models, it's probably going to break the length. Some of the bigger models may be able to handle it, but most of the large language models are not going to be able to handle such a large piece of text. And again, this is just one article. Maybe I had an entire book or an entire training manual, and that's certainly going to be too large. So what I need to be able to do is take that document and then run the question that I had, what was the first machine to run algol W, onto that document set and then be able to extract out any relevant snippets that might have the answer to that question. And that's essentially the retrieval part of Retrieval Augmented Generation. And then what we're able to do is take the relevant snippets from that document, combined with a fancy query that says, hey, only use the information in these relevant snippets. Please don't use the data from your training set to answer this question. And then the model will be able to come back with an answer essentially from that document. So in short, it's basically taken the bits of that document it thinks are relevant, popping it into the large language model and saying to the large language model, hey, use these bits of snippets of information to answer this question. That's essentially the RAG pattern, but I'm going to go through that in a little bit more step-by-step process. However, just to prove this works, this is actually using Jina under the hood, but it's using GPT-3.5, the same model that got it wrong 2 seconds ago, to answer the question. So if I run python main7.py, it is now going to use that RAG pattern to answer the question, and you're going to see that it's going to come back and say the first machine to run Algol W was the IBM 360. So previously it got it wrong, and it's now got it right. So now that we see how RAG solves the problem, I want to break down exactly how it's working. And to do that, I need a much simpler example than a giant PDF document. So what I'm going to do is I'm going to use a very small limerick that I wrote, which will allow us to really simplify what's happening under the hood. So this limerick, yes, it is tiny. It could just go in the context of the large language model. It wouldn't need to be split up, but I think it demonstrates really well what's happening in RAG because it's such a simple concept. So it's a limerick. It's got 5 lines. There once was a dog called Fred who lay in a comfy bed. The bed was covered in cheese right up to her knees, so she kicked off whenever she wanted fed. It's a terrible limerick. I made it up, but I think it's going to demonstrate what happens really well. So for this limerick, I have one question, which was, what was the name of the dog who lay in the bed? Now, if we look at that limerick, it's actually pretty simple to answer. You can see the name of the dog was Fred. And the answer comes from line 1 and line 2. So line 1, there once was a dog called Fred. So we're saying there's a dog called Fred, but we're not saying at this point in time where the dog was, whether it was lying in the bed. We're just saying there was a dog called Fred. The second line, the second snippet, is actually giving the context information, who lay in a comfy bed, right? So if we ask the question there, what was the name of the dog who lay in the bed? You need snippet 1 and snippet 2. You know, the fact that the bed was covered in cheese right up to her knees, so she kicked whenever she wanted fed, none of that information is relevant to answer that question. The only thing that is relevant is line 1 and line 2. Before we start splitting up the document, I'm going to demonstrate how the LLM part works. So to answer how the generation part works of Retrieval Augmented Generation, I'm actually going to use Poe here. I'm not going to use the GPT models. I'm going to use Mixtral 8x7b chat. I could use anything I want there. I could even use something like Gemini, but I'm going to use this for just now. And what I remember earlier on in the video, I said, we're going to instruct the LLM to not use its own data sets, but use the snippets to answer the question. This is exactly what I'm doing here. So you see it says, use the following pieces of context to answer the question at the end. If you don't know the answer, just say that you don't know. Don't try to make up an answer. Do not use your own knowledge base. Just use the information in the context. Use 3 sentences maximum and keep the answer as concise as possible. So I'm instructing the LLM at this point that I'm going to give it some information. I want it to use that information to answer the question. Don't make up an answer. Don't use your own training data set. Just use the context that I'm giving you. Then I give it the context. So in this case, I'm saying there once was a dog called Fred who lay in a comfy bed, my little poem. And at this point, I'm giving it the full poem, yeah? And then I'm asking the question, what was the name of the dog who lay in the bed? And because it's small enough, it's going to come back with the answer, and it's going to say the dog who lay in the bed was named Fred, and it's absolutely spot on. So it's got that answer. Now, it's never going to have that information in its own knowledge base in the first place because it's a poem I made up, so it doesn't exist on the internet. So this is where I'm extending the knowledge base with my information. But as you see, how I'm really doing this is I'm just inserting that information into the prompt, and then it's using that information to answer. And this is really the sort of the generative part of retrieval augmented generation, right? So it's generating an answer here. The dog who lay in the bed was named Fred. And then essentially it's doing a bit of augmentation here, which is it's taking that snippets of information that it's got, right? So in this case, it's the full poem, combining with its own knowledge, and its knowledge is about how to answer the question because it understands how to answer the question and what queries are, etc. And now it's using that to come back with the answer. The dog who lay in the bed was named Fred. Now, let me just clear the context here. Now, if I just use a slightly different prompt, I'm going to use all the same sort of prompt template that I had before, use information in context. But this time, if I just say there once was a dog called Fred, and ask the question, what was the name of the dog who lay in the bed? Let's see what the answer is. And if we look at the answer there, it gives a sort of weird answer. The name of the dog was Fred, as stated in the provided context. There once was a dog called Fred. No information is given about Fred's bed habits. So it gives a bit of a weird answer, but it's essentially saying it doesn't know the answer. If I go into something else, like let's go into Gemini Pro for a second, and you can see Gemini Pro gives a similar answer. The provided context does not mention a dog lying in the bed, so I cannot answer this question from the provided context. Now, if I wanted to, I could instruct this not to give such waffly answers in that sort of template, and I could say, just say don't know, and then it would probably do that if I coerce it into do that. But you get the point that it doesn't have enough information in the context here because I've given it only one line of the snippet. So to be able to answer, I need to either give it the whole context or I need to give it enough snippets. So if I just add another snippet in for a second, this time I'm going to ask the exact same question and I'm going to have the same preludes there, but this time I'm going to give it, there once was a dog called Fred who lay in a comfy bed. And now I'm going to ask what was the name of the dog. And of course, it's now got enough information. The dog who lay in the bed was named Fred. But now, if I have the exact same preludes as I did before in the same context, there once was a dog called Fred who lay in a comfy bed, but this time I ask the question of what's the gender of the dog, you're going to see the text does not provide information on the dog's gender because I haven't provided that. That is further down the snippet. If you remember, I don't specify the gender of the dog until much further on. And to be able to answer that question, I actually need to provide everything. So now if I put the full context in, there once was a dog called Fred who lay in a comfy bed. The bed was covered in cheese right up to her knees, so she kicked whenever she wanted fed. Now if I ask this question, Mixtral is going to come back as the gender of the dog is referred to as she, and her name is Fred. And again, this is the augmentation part combined with generation. So it's augmenting its own knowledge, and its own knowledge is it understands things like pronouns, it understands things like gender, it understands language, of course, and now it's combining it with the knowledge on the context to be able to answer the question. But to be able to answer that question, I have to provide the right snippets. If I just provide line 1 and line 2, it doesn't have enough information. If I provide line 1, line 2, and line 5, it has enough information. Or if I provide it 1, 2, 3, 4, and 5, the full context, it will have the information. So what I need to be able to do is retrieve the right snippets of information to feed into the large language model so it can come back with the right answer. But as you know already, the problem is large language models have very, very small context windows to work with. So we need to be really clever how we do that retrieval to be able to come back with those answers. So to visualize this for a second, you can start to get the idea of what's going on. In the far right-hand side, I've got the result. I've got the LLM stage, the generative stage, or even the augmentation and the generative stage here. Whereas I've got this system prompt that's saying use the context to answer the question, don't use your own knowledge. I've got the prompt, which was what was the name of the dog who lay in the bed. And then the context here is chunk 1 and chunk 2. So to be able to answer that question, I need there was once a dog called Fred, and I need who lay in a comfy bed. Again, if I was answering the gender question, I would need chunk 1, chunk 2, potentially chunk 4, and potentially chunk 5 to have the full context. If I don't provide those chunks, then I'm not going to be able to answer the right questions. And this is the retrieval part, right? In order to get the right answers into the LLM in its context, you need to play this game of being able to get the right chunks and then be able to put that into the context. That's the important part. And if you get that wrong, then you provide the wrong chunks. Let's say I provide chunk 3 and chunk 4, then it's got no chance of answering the question. So it's about being able to look at that document. Remember, that document is generally too big to answer the question, and be able to break that down and provide the right information into the LLM so it can augment the snippets with its own knowledge and then generate out the right answer. So we're now on the retrieval stage. So now that we understand what the LLM is doing and how we need to feed the LLM with the right chunks, we really need that optimized retrieval process to be able to feed the right chunks into that LLM. Now, to do that, what I am going to have to do is take my query, what was the name of the dog who lay in the bed, and then be able to perform some sort of search against my document. So in this case, it was a poem, but it could be the Emperor's Old Clothes, or it could be a training manual, or it could be a database. It could be anything, but it could be an e-commerce product catalog. But in order to get a search back, I need to be able to take that prompt, what was the name of the dog who lay in the bed, or, what was the first machine to implement alcohol, W. It doesn't really matter what the question is, but I need to be able to understand what that question is, and then ask that question of my document store and be able to get the right snippets back, right, in as concise a format as possible, so that I can feed it to the LLM so it can come back with the right answer. So there's 2 things that need to occur. I need to understand what the question is, and I need to be able to get the right chunks to feed into the LLM. If I get the wrong chunks, I'm going to get the wrong answer. So this retrieval part is really critical. Now, I could do a keyword search. There is nothing stopping me doing a keyword search. I could pass in the query and then what was the name of the dog who lay in the bed, and it might come back with the right answers. But we all know keyword searches are highly unreliable, and it's mainly unreliable because we don't know what the concepts are. I mean, let's say I didn't use the word dog, I said what was the name of the canine, or I said what was the name of the canine who lay in the sleeping device, or who lay in the mattress. If those keywords aren't present, it's not going to come back with the right snippets. So we need a more intelligent retrieval process. We need a way of being able to understand that prompt better, and we need a way of being able to understand those chunks a little bit better and be able to correlate how close they are to each other. And that's a multi-dimensional problem. And this is where this idea of embeddings come in. Embeddings is an old concept. It's been around for a while. And once you get things into vectors, again, multi-dimensional in that sense, then we can perform a similarity search between the questions and the snippets. So if we vectorize the question and we vectorize the snippet, and if they're pretty similar in nature, then we know that it could be a good relevant snippet for answering the question. And that is essentially the retrieval process of Retrieval Augmented Generation. So there is 2 things we have to do. The first one is going to be to essentially vectorize or convert into an embedding what the question was, which is what was the name of the dog who lay in the bed. And we then need to essentially vectorize the chunks. So we need to take this large document, we need to split it up into smaller chunks, because remember, it's a large document. It's too big to be able to pull into the LLM. And we need to sort it into smaller chunks and then be able to convert that into vectors. And this is where Jina AI comes in. So to demonstrate Jina AI embeddings, if I go to Jina.ai embeddings, so if you look here, you see it's got an API key and a nice example curl command. So I'm going to run that for a second to show it working. For anybody thinking about stealing my API key, I can regenerate one in about 2 seconds. So I will do that after this video. But this is really quite nice because I can take this, copy and paste it, and then put it into my terminal. and then run that, and you're going to see it comes back with a whole load of numbers, which is essentially the vectorization of your text string goes here, and you can send multiple texts. So that's pretty much all it's doing, is it's converting your query into a large set of numbers. And if I want to, I can run it against the original query. What was the name of the dog who lay in the bed? And you see it comes back with the vectorized answer. And then of course I could do this against the actual query as well. So all I'm doing is calling Jina with my query and providing the snippet of information that I want, that I've chunked up, to be able to turn into a vector format. So again, if I come back into my slide for a second, in this particular case, you can kind of see there that I have 5 chunks, 1 chunk for each line. The once was a dog called Fred. And then I would be asking for the vector of each line. Now, in reality, and this is where you're going to come into the problem, is that you need to find the right size of chunks, right? If a chunk is too small, then it's not going to have enough information, and then it's not going to come back in the retrieval search. But if a chunk is too big, then it's probably not, it's too big for the LLM, and you're not going to get the right answer. So being able to find the right size of chunks is really the trick. And this is why Jina AI is so important, because actually Jina AI is probably the first open source embeddings model which has a context length of 8K, around 8,000 tokens. Well, it's 8192 exactly, which is the same length as text data 002, which is the OpenAI embeddings model. All the other embeddings models before that were 512 tokens. And you can probably start to see the problem here. 512 tokens is about 300 words, and that's small. If you think about a large document there, only having 512 tokens to be able to vectorize is tiny compared to 8,000 tokens. So you may not be able to get good enough context. And this is why the text embeddings 802 model from OpenAI has been really killing it across the board, is because it's able to vectorize larger chunks, and therefore you've got more context to be able to provide the LLM to get the right answers. So when I do my document search, I'm more likely to get the right answers back. Because if I'm making a query, what was the name of the dog who lay in the bed, rather than having to split it up into 5 lines here, ideally my chunk should be the entire paragraph there, not on a line basis. And therefore I need a decent chunk size to be able to do that. And Jina supports, as I say, 8K of tokens, which is incredible. And that's why Jina AI is important. And then more importantly, I think what's going to happen next year is this is going to kick off a whole thing of competing embeddings models in the future. So what will actually happen is, I imagine other companies will develop embeddings models. They'll all be fighting across each other. And therefore, in the same ways we've seen sort of large language model wars, GPT versus Gemini versus Llama models versus Mistral models. I think we're going to see the same in embeddings next year as well. And I think Jina AI's kicked all of that off. And the nice thing about Jina AI is it is open source. It's tiny as well. They have a base model, but they have a small model, and the small model's great. It runs on your local machine, which is awesome. And it runs really fast, a lot of tokens. So it's also cheaper. Even if I use the API version, it's 80% cheaper, which is huge. But more importantly, I can just download it and run it on my local machine. I don't need to use their hosted API version. I can just run it locally if I want. It's on Hugging Face. Now, that's important because if you think about large corporations and their important documents, maybe it's things like financial statements, maybe it's your annual report that you want to release. Do you really want that to leave your corporate network? Probably not. So therefore, being able to do your embeddings within your own network is going to save cost, and it's going to increase the security of your data, because that data is never leaving your own network. So I think that's really, as opposed to going public and then potentially there's a hack and a leak or whatever. So this ability to have embeddings run on your local network at a good context length is incredible. And I think this is why it's a really important technology. And of course, the results are similar to OpenAI. And if we look at the leaderboards, the benchmarking, and I'll cover this in another video, how to use Jina AI properly. But if you look at the benchmarking on it, the results coming back are equivalent to OpenAI, and even the small model is pretty close to it as well. So I love this model. And the big problem that it's solving here is rather than having to deal with these tiny chunks, we have bigger chunks to work with, which means more context, which means the LLM is going to get it right as opposed to not having the right snippets. So that's a little bit about Jina AI in that sense. So now that we understand why Jina AI is so important, then you can see that having the right chunking strategy, which again, I'm probably going to cover in another video, becomes super important. How do I split up into chunks? Am I going to split on paragraphs? Am I going to cut off text at certain lengths? Again, I might not even be using something like straight chunks like this. If it was code, for example, I might want to use things like functions. I might want to be able to use classes, right? So there's different methods that you would use for chunking. And again, we'll cover that in a different video, not today. But the big thing I want you to realize just now is how you chunk up is important, and how you be able to select those chunks is equally as important. So let's come back to the retrieval process. Now that I've got my chunks, these are tiny chunks, then what I need to do is essentially run each one of those chunks and the query through the embedding process. So once I have chunked up every one of those chunks, then I can store it in an index and I can access it, and I can use something like a vector database. I'll cover a vector database in another video. But essentially what I'm looking for is a vectorized version of each one of those chunks. And then that means in the future, what I'm able to do is when somebody asks the question, what was the name of the dog who lay in the bed? Then I'm going to vectorize what was the name of the dog who lay in the bed. And then I'm going to do a vector search, a similarity search against my document store, and get back the chunks that are closest or most similar to what I want. And now I will show you a really rudimentary version of how that works, just so you understand. And then in another video, I'll show you a tool called llama-index, where you can actually get really quite funky with things and get good results back. Okay, so if we take a look at this code here for a second, what I want you to see is the first thing is that I'm loading the model. So rather than using the API of Jina AI, I've downloaded it locally from Hugging Face, and I'm actually just running it on my local machine. And I'm using the small model, and that I'm able to get the vectors from my local machine, which is really cool. Imagine Jina AI goes under, for example, then it's not locked away behind an API and I can't access it. Here's some of my most important data that I'll have used this embeddings to vectorize. And then what if that model went away, right? If they went under, my company would have problems, right? But because it's on Hugging Face, it's open source, I can download it, I can just use it locally. And they've been really open about how it's trained. Technically, I could recreate the training if I wanted to. So I think that's really cool. Whereas if you are using something like Text 802 from OpenAI, now I don't think they're going to go under, but imagine that was suddenly no longer available, right? That could have a massive impact on your business if you weren't able to sort of do that vector queries anymore, right? So I think open source embeddings models really are the way forward in the future. But especially for when you're going to be storing that data, that data is an asset, and it becomes a huge part of your company. So it being locked away in closed source, I just don't think is a good thing. So anyway, as you can see here, I'm using the local version. And then what I'm doing is I'm encoding each of the questions. So in this case, it's the question and the question. But every other time I'm doing the question and the chunk. So what was the name of the dog who lay in the bed? There once was a dog called Fred. And I'm doing that across the board. And then at the bottom there, I'm doing the full version, the full limerick. And then at the bottom, I'm doing a different limerick, one about a parrot called Lily. And the reason I'm doing that is I want to show you what the similarity search results look like for each one of the chunks. Also, the question comparing to itself, because you should get the same answer there, and then for something completely different. So How I'm doing it, I'm doing a cosine similarity search, which is really the same technique as everybody else uses as well. So I'm going to pass in the vectorized version of the question and the answer, and then I'm going to run this cosine similarity search, and I'll get a number to tell me how similar it is. So if I just run this in Python, you can see here the answer is 1.0. So the question, remember the question and the answer were the same there. It was the question. So you can see similarity wise, it's come back with a 1.0. It's saying, well, the two vectors are the exact same. So of course they're similar. So the first, remember this one here is line 1 of the limerick, and it's saying it's 79% similar relevant. The second line here is 86%. And then the third line is 77%, and then 68, 71. And then what's most important here is rather than providing line 1, 2, line 3, line 4, line 5, the last thing here that I said was, put the full poem in, and you can see that's got an 87% relevancy. So if I provide the poem as a whole, that chunk as a poem as a whole, then relevancy-wise, it's saying this is the best relevancy here. Now, imagine I had set the retrieval to, rather than giving me just one snippet, imagine I had said give me one snippet instead of 2 snippets, then it would only have the second line to work with. It wouldn't know what the dog's name was. Remember, that was only specified in line 1, but it would know the bed. But if if I asked it to take 2 snippets back when it retrieves its nodes, then it would have this and this. So it's got that 3, 4, and 5 are the least relevant lines. But you start to see why it's really important to have as much information in those chunks as possible, and then have it kind of split out there. Whereas if I've got too little information, then it's, I don't have the context that I need to generate the answer. If I have too much information, then I'm going to bust the context window. And again, there's a lot more complexity into this. So rather than taking the snippet as a whole, you can run it through the LLM, and then you can summarize it and do a whole load of other things as well. This is just a straight similarity search. But you can kind of see here that if I do the similarity search, if I had a couple of snippets coming back, I'd maybe get snippet 1 and 2. But then even here, I might be getting snippet 3. This is potentially a problem because maybe I'm getting, the cutoff here is too low. It becomes a complex problem. So again, this is why it's pretty cool that for something like Jina AI, that I have got a bigger snippet window to work with. I can work with larger context, and that means I can stick in the entire paragraph, or I could stick in a couple of paragraphs, as opposed to having these tiny unrelated chunks all over the place. So now that you understand really what's happening in this case, right, the retrieval stage is really going through these chunks, and then they are vectorizing each one of the chunks. They're vectorizing the prompt, what was the name of the dog who lay in the bed, and then it's doing a comparison, chunk by chunk, and say which chunks are the most relevant to answer this question. And then depending on how many chunks that you're asking it to come back with, and then depending on how many chunks, what the cutoff value is of the relevancy that you set in there, that's going to decide which chunks make it into the LLM context there. So in this example, it's chunk 1 and chunk 2. But again, with Jina AI, relevancy-wise, I would want to put in the whole paragraph, because that means I'm going to get the better answer. Like back in the original Tony Hoare Emperor's Old Clothes example, that's where I'm going to get the relevant example. So once I've done that, I fed in the chunks, then I'm going to get the result as I did before. So if I come back to my code, don't worry, I'm going to do a proper video on how to use llama-index to work with Jina AI, just not today. You can kind of see what's happened is exactly what I've described, right? I've got this embedded model called Jina AI, which is my small model. And then I'm reading my document from the data directory. In this case, it's the Emperor's Old Clothes document. Yeah, I'm now creating an index, right, from my document. So in this case, I'm using the Jina embeddings model, right, as my service context over the documents. And at the end of this, what it's essentially doing is it's going through that document, it's doing the chunking for me. I'm just using the built-in chunking mechanism, not specifying my own chunking mechanism, which is something you're going to want to do in the future. And then once it's done that, you can kind of see I've set a retriever here, similarity top k equals 1. So I'm saying when I retrieve from this index, yeah, I only want the top item, the top node, the top snippet that matches. And again, this is a value you need to play with on deciding how many snippets you want back. Maybe you want 2, maybe you want 3, maybe you want 5. But 1's a little bit aggressive. Maybe you want sort of 5 to get a good answer. The synthesizer is really the LLM, the prompt template, etc. That's where that's all defined. And then the query engine is finally when I run my query, assemble that into the retriever. So it takes the synthesizer. In this case, I'm specifying I want to cut off anything that's got low similarity. So in my my limerick example, I might want to set that to 75, so that I've got all the non-similar answers taken away. And then finally, I run the query. What was the first machine to run algo? Runs it through that query engine. It retrieves the nodes, knocks off anything under 0.7, gives me 1 node back, puts it into the context, puts that prompt template that says only use the knowledge that you've gained, blah, 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 passes it to the LLM, and then with the query there, and then the LLM comes back with the answer saying, blah, it was this. So that is how that works. I will do a proper video on llama-index at some point, but hopefully you have had a proper deep dive of how retrieval augmented generation works, the RAG pattern works in AI, why it's important, right? Because you have traceability of where it's getting the answers from. You have the ability to control the hallucinations, i.e. only use these sources over here. And you've got the ability to extend beyond the data sources that it's been trained on and be able to bring in your data sources to come back with answers. And again, one of the issues that we've seen in the past is that the context lens, i.e. the bit that the embeddings have been too small, because up until Jina AI coming along, unless you were using OpenAI's Text 802, then you were restricted to a very small context length, i.e. your embeddings could only be 512, but now you've got 8K. And again, I think that's the big thing that's going to be changing going forward in the future. So anyway, that is my deep dive of the RAG pattern. I think 2024 is going to be wild with RAG. I think there's a lot of things that are going to happen, right? How you store that data, how you chunk it up is going to become super important. And I think things like knowledge graphs are going to become really important into this as well. And then all the different vector databases. So I'm going to do a whole bunch of videos on the RAG pattern going forward. But hopefully you found this useful and hopefully really helps you understand what the RAG pattern is and how it works. Anyway, with that, I will catch you on the next video.